All right. Algebra 2, lesson 41, using the Pythagorean theorem and the distance formula. Essentially, these two formulas, this theorem and this formula, do accomplish the exact same goal. Both of them can tell you the distance between 2 points on a coordinate plane. Using a right triangle is one way, using the distance formula is another. A right triangle is a triangle with one right angle. The sides that form the right angle are the legs, and the remaining side is the hypotenuse. The hypotenuse would be the side that we would use to find the distance between two coordinate points on a line. Because the area of a square is found by squaring the length of one side of the square, the result of the exploration suggests that the Pythagorean theorem, which is the converse of the Pythagorean theorem, both are true. Let's see. Come on, move to the next slide. Here we go. Pythagorean theorem, which I'm hoping by now that everybody knows, but not everybody's in geometry. That's where we hit it really big. If a triangle is a right triangle, then the sum of the squares of the lengths of its legs equals the square of the length of the hypotenuse. Essentially, if a triangle is a right triangle, then a squared plus b squared will be equal to c squared. Okay, the sum of the squares of the lengths of its legs. Okay, the sum of the squares of the lengths of the legs is a squared plus b squared equals the square of the length of the hypotenuse, c squared. And also the opposite of that is true. If a squared plus b squared equals c squared, if the sum of the squares of the two legs is equal to the square of the longest side of a triangle, then that triangle is a right triangle. Okay, you can use the converse of the Pythagorean theorem when checking if three sides of a triangle actually do form a right triangle. Use the Pythagorean theorem when determining the length of any side of a right triangle, given the lengths of the other two sides. So if we know A and we know C, we can find B. If we know A and B, we can find C. If we know C and B, we can find A. Okay, we can solve for one of those parts. The distance formula between the distance between any 2 points can be found using the Pythagorean theorem. Meaning that we can find a horizontal distance between the x coordinates, and we could find the vertical distance between the y coordinates, and then put those two distances in the Pythagorean theorem. Because the length of the hypotenuse is the square root of the sum of the lengths of the legs, the distance between any 2 points can be represented by the distance formula as well. The distance formula takes those two coordinates and says x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared is going to equal my distance. Essentially, it's doing the exact same thing because we're looking at the differences between our x values. We're finding the distances between the x values. We're finding the difference between our y values. We square those, and then we square root the whole answer after we've added them together. It does the same thing, just a little bit differently. Okay, let's see. Which brings us to some questions that we can work out. Okay, let's see, this starts off, let me go ahead and actually print this, and that way I've got it in hand and we don't have to go back to it. You guys can pull this up. Okay, and then we'll go back to this page. Okay, so what you guys have on your sheet that you should be able to see is something along the lines of what is the distance between 7, 5 and -6, -5. We're going to solve this two ways. First way we're going to use this is the distance formula. Alright, so I'm going to use my x2, my -6, minus my x1, which is 7. Square that, and then we want our y2, which is our -5, minus our, minus our 5. We'll square that. Okay. -6 minus 7 is something like, what is that, -13 squared plus, and then this is giving me what looks like -10 squared. Okay, we're going to go ahead and square those. So -13 squared, I believe, is 169. -10 squared is 100. So that's giving me square root of 269. I'm going to take a calculator here. Square root of 269. Ooh, that didn't look like that came out right, but it does say to the nearest tenth, so let's check our answer key. 16.4, oh, that's right. It does come out to 16.4, okay, which is correct. Now, using the Pythagorean theorem, you could see this drawn out, but really all I'm looking for is the difference between 7 and negative 6. So if I was to look at it on like a number line, where here I have negative 6 and here I have 7, well, this distance here is 6 and this distance here is 7, so that's giving me my 13. So 13 squared. And then the difference between 5 and negative 5, well, that's negative 5 and this is 5. There, from here to here is 5 and here to here is 5, so that gives you a distance of 10. So 13 squared plus 10 squared, you'll notice I'm getting these same things. I'm getting 169 plus 100, but it's equal to c squared. It's giving me 269 equals c squared, and in the end I still have to square root it to get just c, so I'm getting that 16.4 either way. Okay, so it's doing the same thing. Okay. Let's see. Let's look at number 2. Number 2, a cartographer constructs a map of Georgia. This is really similar to I in your homework, so you might pay close attention to this. Over a grid, it says Macon is at 115 on the map. Okay, so you're going to the right 115, up 15. Atlanta is at 175.95. Okay, find the distance between the cities to the nearest kilometer if each unit represents 1 kilometer. All right, this time I'm going to use the Pythagorean theorem. So I'm looking at the distance between 115 and 175. So I could take 175 minus 115. That's going to give me a distance of 60. So 60 squared. Distance between 15 and 95. 95 minus 15 is 80. So I'm getting 80 squared equals c squared. Okay, so 60 squared should be right around 3,600. 80 squared should be, I believe, 6,400. Okay, 3,600 and 6,400. Should give you 10,000. Square root that. Should get 100. 100 times 100 should give you those 4 zeros. So 100 should be your distance. Let's double check our answer here on number 2. And 100 is our answer. You should be able to do that exact same thing on I in your homework. And that's probably one of your tougher questions in there to do anyway. The rest of these really aren't terribly difficult to do. I'm trying to find if there's anything in here. Let's go ahead and let's pick one out from your homework, like, let's pick F, because I'll notice on some of these, actually no, let's do G. It says find the distance between each pair of units, give your answer in simplified radical form and to the nearest tenth. So in this one it says A is 5, negative 5, and B is 9, negative 11. Okay, and just for some of you that really prefer the distance formula, you understand that better. Okay, and we've got our 9 minus 5. That's this 9 minus that 5 squared plus, okay, negative 11 minus negative 5 squared. Okay, 9 minus 5, that's going to give me 4 squared. And this is negative 11 plus 5, which should give me negative 6 squared. Okay, well 4 squared is 16. Negative 6 squared, and you have to do that in parentheses, is 36. Okay, I'm going to add those things up. 16 and 36, I think is 52. 36 plus 16, 52. Okay, we want this in simplified radical form, which means we're going to break that down into primes. Find the prime factorization of 52. It'd be what? 2 and 26. That's 2 and 13. 13 is already prime. So this is 2 square root of 13, because we want to take out 2's, because there's a little 2 there. So 2 of something. I have 2 2's, so I bring that out as 2. I get 2 radical 13. The other parts of the question said find it to the nearest tenth. So 2 square root of 13. It comes out approximately to be 7.2. So that's how you would use the distance formula. You still could have used the Pythagorean theorem there. Let's look at H. H in your homework is one that might give you fits. Okay. Find 2 possible values of k so that the distance between 1k and 6 negative 3. Okay, we want a distance of 13. Okay, so there's 2 ways we could set this up. Let's see. Let's go ahead and use the distance formula. Let's say we got 6 minus 1 squared, okay, plus negative 3 minus k squared, and this has to equal 13. Okay. So let's see, let's go ahead and let's keep going here. We got 6 minus 1 is 5 squared, plus negative 3 minus k. Okay. Well, negative 3 minus k squared will actually come out as a FOIL. Okay, so what you're looking at is negative 3 minus k times negative 3 minus k. All right, so we may have to rearrange this around a little bit, but negative 3 times negative 3 is 9. Negative 3 times negative k is plus 3k. Negative k times negative 3 is plus 3k. And negative k times negative k is k squared. Okay, so we've got that. We can go ahead and simplify that a little bit, because we'll end up with 25 there. And let's rearrange this so that we have k squared plus 6k plus 9. Okay, we can go ahead and add our 25 to our 9. So we're getting k squared plus 6k, let's see, plus 34, I think. Plus 34. Okay, 9 plus 25, 34, and all this equals 13. Okay, now a really good way to get rid of a square root is to square both sides. Okay, so that's going to give me k squared plus 6k plus 34 equals 13 squared, which is 169. I'm going to subtract 169 from this right here, and that's going to give me k squared plus 6k. 34 minus 169 gives me negative 135. Okay, what I'm going to do here is let's see if we can figure this out. We put a k here and a k here. Only way to multiply 2 things to get a negative is to have a positive and a negative. Things that multiply to be 135. Well, we know it divides by 5, but that gives you 5 and 27, which has a difference of greater than 6. We need something with a distance of 6. Let's try 135 divided by maybe 15. Okay, 15 and 9. All right, well 15 and 9 have a difference of 6 because 15 minus 9 is 6. All right, so if I set k plus 15 equal to 0 and k minus 9 equal to 0, well then k equals negative 15 or k equals 9. See if our answer comes out, and that's what our answer comes out to. So you can see why we would want to do this one maybe together, as it's kind of complicated. There's a lot of different things you might have been able to do there. Probably could have used the Pythagorean theorem on that as well, but it's just the way we chose to do it here. I'm going to assume at this point I've kind of covered maybe the bulk of your more difficult questions on this. If you have any questions, get a hold of me, let me know, and I'll try to help you out.